Okay, so I don't think we have anything written in the agenda, and I feel that's probably my fault because I mentioned I wanted to discuss DRA. Do we have any other topics we wanted to discuss?
I wanted to discuss, I think we did a little bit of thinking, just a couple people on our side on the provisioning request custom resource and just how we were thinking about it, at least initially. So after we get out of DRA, we can do that.
Yeah, we don't have Martin today, so I'm happy to discuss, but maybe at some point we probably need to invite him again.
Okay.
Okay, so I'm going to start with DRA, if that's okay. And so what I was thinking about is specifically the fact that DRA is expanding into scheduler scores, and so essentially pod being able to specify preference for what type of hardware, either what type of hardware, what configuration of hardware it wants. So as I understand, it can basically specify it prefers one type of GPU over another, and it can also specify it prefers it to be like GPU to be sharded in specific way. And I'm worried about this, and I don't know if I'm right to be worried, and I don't know what the kind of right solution is. But I'm worried because in cluster autoscaling, and I believe in Carpenter as well, we don't take into account scheduler scores and pod preferences, and it's really hard to do it. At least from cluster autoscaler, the challenges are kind of scalability, and just running those scheduler scores would be probably quite expensive. But also, we're not making decisions for individual pod, and it's unclear what should be preferred if there are multiple pending pods. And even more so, how would that combine with things like Expander, where the policy is maybe to like use cheapest machines, or like we have a bunch of different expanders optimizing for like bigger machines or like better bin packing and so on. And it's kind of unclear how that sort of preference would be combined. And we already see users today quite often getting confused with things like preferred node affinities, and they expect Autoscaler to essentially provide nodes somehow prioritizing the preferred node affinities, which it doesn't. And so this is already an issue, and I'm worried with DRA it may be more of an issue essentially. But yeah, I'd love to hear everyone else's opinion.
Yeah, so I think on our side, also a big problem, like telling users how to reason about it and like users understanding how preferences are treated, although it's a bit of a different problem for us, like because we like our position on preferences, at least today, is that we will respect them, like require them effectively and treat them as required in our scheduling simulations, but then like they're not hard required. So effectively, like if we can't succeed to schedule with the hard requirement, then we'll basically kind of back off of that requirement, treating it as not actually required. But basically the initial scheduling loop will basically enforce all of the preferences requirements. And then if that doesn't succeed, then we'll back off and remove the preferences slowly until we're able to succeed or we fail generally. Which I think is like it's effectively the behavior that they're trying to get at with DRA, as I understand it. Like they're trying to say, like, please like try to get this thing, prefer this thing, but then if you can't get this thing, fall back to this other thing. Which I think is aligned with the way that we're thinking about preferences. Although I know that they're like there's like some other use cases for preferences that we've heard about, particularly with like topology spread, where it's a little bit difficult to reason about it. Or I guess anti-affinity, I'm thinking about, not topology spread, where users want to say like the fallback behavior, I think is like a pretty reasonable stance, at least from the way that we perceive it. But in terms of like pod anti-affinity preference behavior, I've heard use cases around like, I want you to spread my pods as much as possible, but like not completely. Like I want you to like I want it to basically be like similar to how Cube Scheduler would do it, like schedule them kind of as much as possible, but like not actually spread them one per node. So like I kind of want like this concept of like topology spread, but not really. Like I want like you to give me basically max 3 pods of this application per node or something like that. And there's not really a good semantic or a way in Kubernetes to represent like I want a percentage of my application pods across like maximally on this node. But I've heard that use case, and people are trying to achieve that with preferences, which it isn't really handled very well, either in autoscaling or in kubescheduler, as far as I can tell. But I think the fallback behavior makes sense. I guess I'm curious, like, y'all completely ignore them, which I guess presents a kind of a different challenge and a different problem when it comes to fallback.
Yeah, I think that this may be due to some difference in our bin packing algorithms. So I think you look more at individual pod and define node based on this, whereas we try to bin pack, like basically take a group of nodes and try to bin pack all the pods on them. So there isn't really much of an individual pod kind of making a decision. It doesn't really fit into the model where we just say, okay, let's try to pack all the pods on 8 core VMs. So I think that's kind of the difference in the bin packing model. But I'm thinking even assuming, so I wasn't aware that that's how you handle the preferences, right? So I imagine if you have this model, then maybe even if the fallback list is longer than 2, that doesn't actually change anything. You can just iterate through this. But how does that play with settings specified on node pool? So if you say, if the pod says basically, right, it wants 40 gigabytes of worth of GPU, I don't know, 80 gigabytes, whatever, and that can be like 3 different GPUs. I guess those GPUs just all need to be specified on node pool, right? I'm trying to figure out basically if pod can prefer something that conflicts with the node pool configuration.
I see. It can, but it wouldn't be satisfied, I guess. Right? Because like we would basically try to schedule it, see it doesn't work, and then we'd fall back to not respecting the preference. At least that's how we handle it today. But which again, I think is the use case as I understand it. Like they're just trying to achieve preference fallback behavior.
Yeah, that makes sense. So maybe it's less of a problem, I guess, because you don't have a way to specify like the expander of cluster autoscaler, right? So this is basically the scoring function I'm optimizing, which is completely separate from pod preferences. And because you don't have this user specified strategy, this is less of an issue.
Yeah, I think there's perhaps, I think we thought a little bit about it. We do have an issue that's kind of tracking this whole, like the interactions between node pools and pod preferences and all these different ways you can specify preferences in your pod requirements that kind of create this. And it gets even more complicated when we have this. I mean, you guys have priority expander. I guess we have the concept of node pool weights, and we kind of treat a heuristic where we just say, okay, we'll try the biggest node pool and we'll try to respect all the preferences. And then we'll back off based on weight, and we'll, if we don't succeed, like basically we'll prioritize backing off the pod preferences first, and then we will fall back to starting trying other node pools of lower weight. So basically, node pools of higher weights are prioritized first before pod preferences, and then the node pools of lower weights are then tried if we can't satisfy those preferences, as far as I understand it. Actually, maybe the other way around. I forget exactly, but basically regardless of whatever ordering it is, there's like this, we're not considering all of the like things in unison because it may be too complicated to do so. I mean, there's perhaps a way we could do that computation, but I think it's quite complicated to be able to like consider all the things at once and determine, like basically have a scoring strategy for determining like, okay, you have this set of preferences and you have this set of node pools, and actually like this node pool in the middle with this preference that's also in the middle is like the best combination of things based on our scoring strategy. Like we don't have nothing like that today. It's like literally just try the thing that's highest first and then start backing off of it.
Okay, I see.
Which I think makes it computationally easier to do, but
yeah.
But it's definitely not ideal.
I'm wondering, and this is just for my understanding. So if you have a case where you have, let's say you have node sizes that have power of 2 cores, so you can have 8, 16, and so on, and you have 2 pods and 2 pending pods, right? And one has 9 CPU requests and the other has 2 CPU requests. So basically, if you create 16 core VM, they just both go on the same VM and they have different preferences. Am I correct in thinking that because of the kind of the way you sort pods, you're essentially just going to go by the preference of the larger pod? Is that what's going to happen there? Does my question make sense?
Yeah, no, it does make sense. I'm trying to remember. I believe the preference of the larger pod gets respected, and then I think the preference of the smaller pod would also get respected, assuming we can create instance capacity for it. Oh no, actually that's not true. It would schedule. Sorry, no, it would. Oh no, that is true. Yeah, so we would basically. I'd have to look at it again, but I believe what we would do is we would schedule to like a new instance for the first pod that's big, and then we'd schedule a new instance for the second pod as well. If those preferences conflict with each other, like basically if you couldn't satisfy that biggest preference on the second pod that you referred to with the existing instance type that we just created for the first pod, we would create a new instance type.
Oh, that's
because we'll respect the preferences first before we'll actually because we treat them as required to start.
Oh, that's really interesting. But what about scheduler then putting the pod on the different node than you predicted? Like, what if the scheduler just puts the small pod on the big node collocated with the larger pod? Then you just delete the instance you created for it, right?
Yep.
Okay, cool.
If you're correct, if there's a race there, then yeah.
Yeah, it doesn't even need to be the race, right? Depending on the scheduler configuration, other priorities. Like there is the priority for spreading all packing together. So you can actually have a score that prefers more packing nodes or spreading pods, depending how this is configured on scheduler level. I think even without races, it's possible that because this is just linear combination of numerical values. So essentially, some preferences can override. I don't know. I don't think it's very predictable.
Yeah, this is kind of an inherent issue with preferences that kind of creates this unpredictability, particularly with auto scaling, I think.
Yeah, but okay. So it seems. Yeah. Sorry.
No, go ahead.
I just wanted to sum up. So it seems the DRA one of kind of fallback, at least if the scores are essentially intended to achieve fallback behavior, that may actually not be as big a problem for Carpenter because you already kind of do something vaguely compatible that maybe is not that difficult to adapt. Is that fair statement?
I think that's correct, yeah.
Okay. Okay, so I wasn't aware of that. So maybe this is cluster autoscaler specific problem that we need to solve. So I think I don't have really anything very smart to say at that point. I need to take what I learned from you and think about it and maybe come back. So unless anyone else has any comments on DRA, maybe we can move on to the next topic.
I guess there's a bit of a question I have here on just like preferences in general and how like autoscalers should reason about preferences. Like this also is another area that I feel like I don't quite understand I think you said that there's some detail in cluster autoscaler about how it reasons about pod scheduling that might make it slightly different from how Carpenter handles it and create problems when it comes to preferences. I'm not quite sure, but I guess I'm curious if there is an area or there's room that we could like take a similar stance on pod preferences or have some sort of, I don't know. I think we've run into problems with this concept in certain ways. Like there's some use cases like I was calling out that aren't easily met by pod preferences that we could perhaps align on. But I'm curious if there's like, is there a way that we can have like a shared feeling on pod preferences? Or do you think that that's like unachievable based on how y'all are doing things today?
It's definitely not easy. I don't have any good idea right now, but maybe there's something we can think about. So just to kind of, I can try to explain why it's difficult for us. I think it's in Carpenter you have this model where, right, you look at a pod and then you select an instance for it, as I understand. Versus in cluster autoscaler, we basically kind of go by node pool or node group, whatever. We for each of them, because they are homogeneous, for each of them we just basically do a bin packing simulation where we take all the pods and we just keep adding nodes to see how many nodes we need to add to satisfy what number of pods. And there isn't obvious way. Like we basically, all the scheduling simulations we do assume scheduling all the pods on identical nodes, and that kind of doesn't lean itself very easily into respecting preferences if they are different between different pods, because how would you choose which pods you want to select? I guess we could do the same thing where we treat them as required. But then I wonder, yeah, I mean, then that would almost guarantee races with scheduler, because I think because we add a bunch of identical machines and then sometime later we would add another bunch from different node group. So that would make any sort of scheduler races, I think, maybe even more probable, just because the timing would be a few seconds off. So maybe it's something where we can try to think of something similar to what Carpenter is doing, but it's not very obvious how that would work and if that would scale or even work really from perspective of races.
Yeah, I think we generally just, I mean, up to this point, we've just kind of accepted the races that happen and just downscale based off of them if they happen. But it's definitely not, it's not ideal. Like there needs to be, and I think this is the missing bit, which we kind of talked a little bit about, which is this thing of like I need to communicate to the autoscaler that it's a preference and you can fall back on it. But if I can satisfy it, I need the scheduler to be aware of the fact that there is going to be capacity, like I have been able to satisfy it, basically, so that you prevent the race from happening on the scheduler side.
Yeah, I know there is some thoughts in the scheduler, like SIG scheduling, specifically around pod topology spreading. So one problem we've seen a lot with pod topology spreading is kind of the stockhouse scenario where if you have, let's say if you have 3 zones and you want pod topology spreading with do not schedule and max what's the difference? Like max spread of one, max difference between zones. I don't remember the name of the fields of one. So basically, you only allow a difference of one replica between zones. If one of your zones is stocked out, that prevents you from scheduling anywhere, essentially, because you cannot schedule to the place where you're out of capacity because you're out of capacity, and you cannot schedule anywhere else because scheduling constraint forbids it. And then the problem is with the preferred or whatever fallback schedule anyway, I think is the name, topology spreading, because it's a scheduler preference and autoscaler ignores those. And even if it didn't, the problem is usually, or at least very often, you may already have capacity on existing nodes, so autoscaler doesn't even get to react, so that tends to not do very much. And it's basically, a lot of people would like to spread their pods, but it doesn't really work in practice on the zonal topology key specifically. And we've been having a lot of discussions with customers about this, and in general, no good solution.
Sorry, I think I missed the initial bit. So it's their zone isn't available or something like that, and therefore like you just get stuck.
Yeah, so the problem is if you have, imagine you have like one pod in each zone already, and then for some reason you cannot add node. I mean, some reason you're basically, provider is out of capacity. You cannot add any more capacity in zone C, and then you can schedule one more pod in zone A and zone B, and then you cannot schedule pods anywhere because in C you cannot add more nodes because provider is out, and in A and B you cannot add because max queue would be violated. So basically, scheduling constraint has the problem of it doesn't really allow for fallback unless your zone goes completely out and like all the nodes go down and it sort of disappears. But that's not a very common failure mode in my experience. So in most cases, basically topology spreading means you just don't run if one zone is out of capacity, which is terrible. Or you do the schedule anyway, but then the problem is if there is any capacity, it just goes to the existing capacity. And so autoscaler will not even attempt to spread it out because it just schedules. It never gets to the point where autoscaler does anything.
Yeah, I think so. Kind of like I mentioned earlier, there's like two classes of problems here. There's the fallback one, which I think is much easier to achieve, and this is why I'm curious if like y'all would think about how this might work in cluster autoscaler, because I think what I think the right behavior is at least for fallback scenarios, if you're trying to specify fallback with preferences, is it gets respected by the autoscaler if it can be. It gets removed if it like can't be satisfied at a given time. And potentially like with consolidation or underutilization, if you're doing replacement, like if you're able to satisfy that preference later, maybe you allow it to be consolidated over to that thing, because now the preference can be satisfied. Um, and the missing bit today seems to be the thing you're talking about, which is like the race condition on the scheduler. The schedule, like this problem basically goes away if like at least from our perspective, like if Carpenter or cluster autoscaler as well, I guess, if like you're the one making the scheduling decision, this problem goes away because like the capacity, like the capacity is coming. So like you can be aware of the fact that like, okay, like hold this pod around because the capacity is going to be here eventually. There's just like the lack of communication mechanism between the autoscaler and the scheduler, I think, is what's causing these issues where this kube scheduler isn't aware the node is coming. Like we have, because we deploy like these node claims to our cluster, so like that resource exists. So there's this thing that says like, hey, this capacity is on its way, but like it just isn't here yet. There's no node representation. The kube scheduler doesn't know about it, so it just says, okay, this is all the capacity I have. I don't know, 2 seconds later, I'm going to get this other pod or this other node.
But I mean, even that, like even if scheduler looked at those, right? I assuming, like, why wouldn't it schedule the pod before you even first like consider adding more capacity? I mean, if cluster utilization is 100% sure, but like chances are in many clusters you will have some sort of spare capacity. So in that case, even scheduler looking at this
Yeah.
wouldn't
Yes.
really help because it's not about node coming up. It's really about ability to create node before that is even done.
Yeah. So then there's the second class of problem, which is like, do preferences mean like respect them if I don't already have the capacity? Or do preferences mean like respect them always, regardless of whether I have the capacity or not? Which I think some users want one and some users want the other, depending on, and the fallback behavior is different, right?
And then for cluster autoscaler, most people I think run priority expander or like something similar. We have our version on GK, which is whatever similar concept. And how would pod level priorities combine with this? I guess your equivalent would be weights. It gets kind of a bit messy there, where the user says they prefer specific, like use this configuration first, like this node pool first, and use this node pool as fallback, but then pod specifies some sort of preference which may or may not conflict. I think my ideal world, the way I'm thinking about this, would be to go more into this. You really specify this at priority expander node pool, that sort of concept level, and not on the pod. And then your preference is implied by your selection of node pool. I don't know if there is any reason with Carpenter why you wouldn't have a whole lot of node pools. Like, can I have 100 node pools? Just create one for each workload if I really need to. I don't know if there is some sort of scalability limitation there. Yeah, so then that would just solve it because you don't have to. You basically get away from the problem of, I think, different pods having different preferences and not combining with kind of admin specified or like platform administrator specified node preferences just because there is just one preference specified in one place.
Yeah, I guess in practicality, it seems like that doesn't work, right? Like I think they're different personas that are applying different sets of constraints. I guess I'm curious in practicality if like you see that level of like full isolation with explicit fallback across node, like that seems like just a nightmare of overhead for like a cluster admin to have to maintain.
So I think what we've seen is, in terms of feedback we've been getting, is there are some preferences like topology spreading, which generally lives with the application owner, but actually the things like whether you want to use like one machine series or the other. So in GKE that would be, I don't know, like C2 versus N2. But whatever, I'm not super good with Amazon names, but that often rests with the platform admin, who makes this a sort of central decision for budgeting reasons. At least that's what we've been seeing, where the admin actually wants control over this, and they don't want all the developers just using the most expensive, best hardware for cost. I mean, incentive, I guess, reasons, right? As an application owner, I may just want the most of the best. If I'm not the one paying for it, essentially.
Mm-hmm.
So a lot of this, but like in terms of statistically how big of a percentage it is, I don't know. I'd imagine it probably correlates with organization size and kind of the internal organization, really.
Yeah, I think the feeling I'm getting from this is that we need to keep talking about this. Like, there's definitely a lot more discussion we need to be having. Do you guys have an issue that's covering like how y'all think about this, or I guess are there people that are asking questions about it or asking y'all to think about it at all?
You mean in general about preferences or about DRA or
Preferences, but I guess we're talking about in the context of DRA, but also just general.
not as much, because the answer right now is we just ignore them in cluster autoscaling. So that's very simple answer. I'm sure there's plenty of issues saying, I'd like you not to do that, but I don't think there is any with meaningful discussion.
Okay.
But yeah, kind of going back to topology spreading, I don't have the cap at hand, but I remember someone from SIG scheduling basically trying to deal with the problem specifically for topology spreading by doing something like do not schedule for X seconds and then fall back. So they kind of, instead of having explicit communication, just trying to solve this by having time-based fallback and hoping that this gives enough time for autoscaler to provide a node, which looks like a thing that probably will work in some percentage of cases, and then obviously it's not going to be very reliable, but yeah, but there is cap, I think, somewhere. I can find the link later. So this is more in terms of heads up that this is kind of how some people in scheduling are thinking about those.
Got it.
Okay, so do we want to move to the next topic then?
Yeah, I think so a few of us are doing a little bit of thinking around like how Carpenter wants to reason about this concept of provisioning request. I think we kind of, I guess I'll share my screen, maybe it'll be helpful as well. We briefly talked about this last week, or I guess maybe it was a few weeks ago. Just in terms of like use cases around using provisioning requests as I understand them. So there's the case of I want to basically pre-provision capacity for jobs to run. Whether that like the atomicity of that capacity is like orchestrated by the actual like resource itself and like the controller that manages that resource, or if it's like some other thing that's responsible for managing like the atomicity of that thing. Like basically the question of like whether like if I request a given set of capacity, if I don't get the capacity, does that capacity get deleted? Like I think we can perhaps decouple that question from like the actual concept of like give me the capacity ahead of time, because I guess I'm a little skeptical of like whether that should be orchestrated by the provisioning request itself or something else. But regardless, I think the use case is like I need the capacity ahead of time. So
There's the use case of I need capacity ahead of time, both like fill it up as I like for jobs as like give me the capacity, and then once the jobs get scheduled, then it should use up the capacity and shouldn't keep scheduling more capacity on top of that. There's the use case of I want to always have a warm set of capacity available on top of things for like a deployment, for instance. So I need to have like 2 replicas of warm capacity available for an application pod, so that if I get a burst, I can immediately schedule that pod, and then I'll keep kind of maintaining that overhead or that headroom or whatever you want to call it as I go. And then likewise, as if it's scaled down, it would also go like scale down with it. And then I believe I'm trying to think of other use cases that we discussed.
There was emulating a node group, right? Where you just want to emulating a node group, like so you just spin a set of capacity, even if the cluster is totally empty and you want to hold that open. But if new, it's kind of like a base, like a floor of the cluster, right? Like I want to have 10 instances in the cluster, and if pods go in, I don't want to spin 10 more nodes, but I basically want to have this kind of base layer in my cluster.
You're muted.
So basically, a kind of equivalent of mean size of cluster autoscaler node group expressed in a different way.
So globally, I think perhaps maybe it could be global, could not be global. Like you have the ability to differentiate those things. It seems like basically there's like the application based semantic here, which is the 2 use cases I called out, and then there's like the cluster admin semantic, which is what Ellis is calling out, where it's like I either want like a minimum set of capacity that I can always have available to me, or I want like a minimum overhead of capacity. Similar concept, like either use up the capacity because it's a minimum, and like once it gets used, then just like scale from there, or like give me that capacity overhead just generally across the cluster all the time, and like keep it warm.
So the ones you described sound very understandable to me. So I think today the equivalent would be essentially balloon pods that are either managed by deployment or just bare balloon pods. So the bare balloon pods just go away after you preempt them. So it's a one-off, or deployment-based ones, which is constant buffer. You use it, they get recreated, and maybe you something like HPA or with custom metric or something to just like have them as percentage of something else, or some mechanism to automatically resize the deployment. Right, that's how you would do this today, which is not super convenient. And then I'm curious in terms of what Alice mentioned. If you have a node pool that has a lot of different types of machines, how would you express it? I want 10 instances. If my instance can be different sizes, feels not very meaningful. Is it 10 smallest instances, or would you just say I want 50 CPUs worth of instances in this node pool?
I guess it's perhaps more meaningful to spot capacity, like on-demand capacity. You're right, like probably doesn't make a lot of sense. You probably would specify a single instance type, or maybe you don't like, you don't want to reason about instance types for whatever reason, or you just want to reason about instance categories, and you're just like, I want whatever instance category like is like network optimized, and I also want like a minimum amount of resource requests, and I don't want to think about like the specific thing that satisfies that. I just want like I want something that has these properties, and that's perhaps useful. But either that, like I want something that has these properties, or I want to express like an array of options within spot capacity, and I don't have the concept, like I don't know the concept of availability, so I have to just like send it off to the server to figure it out.
Okay, fair enough.
Yeah. So I guess a few things as we were thinking about this problem. Like one is that it sounds like we basically have like 2 types of things. Like we have like the concept of like fill up the capacity or like always keep it. So there's like this concept of like pods like match a particular like set of like headroom, and as like if it matches the headroom, basically you don't like continue to like respect the headroom in your scheduling simulation. So ideally, like this concept is like a specific concept for autoscaling, and like as like the autoscaler reasons about headroom is like some additional capacity, how that gets reasoned about, I think we can talk about, but like
it gets reasoned about as additional capacity, and then either pods like match that headroom in a way that would cause the headroom to get like smaller and smaller from the autoscaler perspective, or that just always gets maintained. So there's like those two different types of things, either on the node or pod level. And then I think as we were thinking about it, like this kind of approach here with the provisioning request, necessarily like thinks about this concept in terms of pods, which I think as we were kind of thinking about this concept, even like we can perhaps put the node case aside for a second, like expressing the headroom capacity as like a pod semantic, I think is the right like semantic. Like it makes sense to me because there's all these like like semantics on pods that kind of you necessarily want to be able to express with your headroom concept. Like you want to be able to say like spread my pods across these topologies, like put them like one per node, so give me pod anti-affinity, like they select on this particular type of capacity. Like I want this particular instance type or this particular type of like network optimized instance or something like that. Like you have all these requirements that are specified at the pod level and it just kind of makes sense at the pod level. And if you're just like expressing pods or expressing like headroom as like an application overhead thing, or it's like fill up the capacity thing for like my jobs, I think that makes sense that like that is reasoned about in terms of like a pod semantic. Like, so I think this is perhaps like close to how we were thinking about it. We can perhaps touch on this later, but I guess I'm curious, and maybe this is why we need Marcin here. Like, as we were reasoning about this, like these pod sets reference out to pod templates, and this necessarily like requires a user to have to like create a pod template object and then ref out that pod template object. I think also we were kind of curious like why there were multiple pods specified, like pod template objects specified within this provisioning request spec. Like why do you need to be able to reason about like multiple pod templates within a given headroom overhead concept? Perhaps like headroom is like just a single pod representation with like a certain set of replicas. I think the reason for this, as far as I understand it, is like it's all atomic capacity concerns. Like it's like I need this set of pods which have perhaps different like requirements on them, like different pod templates, to all like atomically scale together. And I guess I'm skeptical of the fact that like we can't just represent like a single pod spec with a replicas field as like the headroom concept. So like inline a pod, I'll like show you what we were thinking about here in a second, but like you inline the pod spec with a replicas field and it contains all the requirements you're talking about, like the same like pod semantics, topology spread, node selector, like all of that. With a replicas field, the scheduler, or the like auto scaling scheduler reasons about that without the kube scheduler having to be aware of it. And then you also like layer on the semantic of like pods that have this label, like select against my, maybe not, I think in this particular like cap, there's like the semantic of like an annotation like matches back to a provisioning request. And I'm curious if we should just drive this from the provisioning request without asking users to have to modify their pods. Like if you say like this provisioning request or this headroom thing, like selects against like any pod that contains this label, like fills up the headroom. And then if that like completely fills up the headroom and goes beyond the headroom, then you start to like provision capacity ad hoc for those pods rather than having it be like used up. So I think
just like one way we were reasoning about this was like a concept of satisfied by. So the provisioning request is satisfied by pods. And if you could do a selector for all pods and all namespaces, and then you get that kind of like baseline experience, or you could do it for, say you're integrating with Q, you could do it for a selector that matches the Q pods. So that capacity, that provisioning request would be satisfied by those Q pods. Or it could be satisfied by nothing, and then you'd be maintaining headroom, essentially, like constantly, kind of the way negative preemption pods work today.
Yeah, I think what we ended up coming around to is like, can we represent all the details of the like all the semantics we need to represent as like a pod template spec? And then can we also layer on this like satisfied semantic, which is the semantic of like that either or case of like either the headroom gets filled up or it doesn't. And it's like a selection mechanism. So like either you can do a match fields, you can do a match labels, like you're driving it through this like headroom concept, but like you're inlining the pods, and then the atomicity piece, which I think is like it's pretty tightly coupled to the provisioning request concept, is like
handled outside of the concept of like headroom or provisioning request. Like that concept is like maintained by some other orchestrator, maybe Q, maybe some other controller that's responsible for defining, like maybe there's an object that we define eventually that's like atomic headroom, and then like that atomic headroom references out the header. Like you could layer things on top of it. But I guess I'm skeptical of like coupling, because headroom as a concept, like there's so many use cases around it, and not all of them are related to like atomic like scale ups and scale downs. I'm personally like skeptical of the fact that like we need to couple these things so tightly, and like perhaps Q itself can be the orchestration mechanism for deploying. Like Q deploys the headroom. It already provisions the provisioning request as I understand it. It deploys the headroom ahead of time. It like knows the jobs, so it has jobs with labels that are satisfied by the headroom, like this concept of satisfied by. You just like select the headroom against those pods so that the pods would fill up the capacity. And then if you're not able to fully get the capacity, like maybe you have a status condition on the headroom that tells you like when the capacity is available or something, or you can like introspect the capacity yourself by looking at the scheduling. Then you know like whether you can or can't go. And then like Q itself could orchestrate like deleting the headroom if it's not able to atomically scale, versus that being like orchestrated by the provisioning request itself.
So Marcin is not here, but I think just based on what I know, I think multiple pod specs and kind of atomicity is essentially the use case, like the driving use case here is for deploying something like job set, which is multiple different jobs essentially that need to essentially gang scheduling across different different pod specs. And I think basically probably if we define it that way, then it doesn't solve the use cases that the batch group had in mind specifically. I think basically where Marcin is coming from was not solving the general headroom, which I'd like to solve using this. But like I think the goal was essentially solving this whole atomicity. Like that's basically the feature of the reason why that was done, I think. So that decoupling this is basically let's make a new API for solving different use cases, which is fair. But I think that's more of the direction. I think specifically part of the intent was ability to consume provider side APIs that allow atomic provisioning, and like that cannot be done in Q alone, just because it doesn't provision nodes, right? So
yeah, I guess the question is like how. Yeah, I guess there's a couple questions for that. There's like, I think for us, like this concept feels so close to the concept of headroom, like because it is like the idea of like I want to provision like some amount of capacity and like pods use up the capacity is like cluster minimums. It's like I have always like it's like an application minimum. Like that concept is like pretty close to what we're talking about here, where like you can either have a headroom that like sits on top of the application at all times, or is like a minimum for the clusters as a floor or ceiling or something like that. And that like is so close to this concept that it's like it feels like we can build like a more generalized concept that both attacks like this use case as well as other use cases. And perhaps we just like need to explore like what the gaps are in this like minimum like like this minimum headroom idea with this like satisfied by, or maybe the API changes slightly, but like I'm curious if we can like explore like what we're missing, like what do we need to orchestrate on top of this headroom concept, or like whatever thing we're talking about here that like is satisfied by this provisioning request atomicity but isn't satisfied by like the headroom API, and maybe we need to build some orchestration layers on top of it or add additional fields. I don't know, but like they're just like so close to each other that like I feel like if we try and like build this and then we say, oh, we'll attack the headroom problem later, we're just going to end up like either having two APIs that look very very similar to each other, and like now users are having to reason about both, and they're like, well, these are close but like not the same, or we end up having to converge them over time, and then that's kind of painful as well. Like users have to migrate.
No, I think Elise, do you want to say something? Because
yeah, I was just going to weigh in a little bit about like the atomicity question, because I think when we went through this exercise, I think we realized that we could support all the use cases we were familiar with, and we could support all the use case that that provisioning request does, except for the atomicity bit. And we were just kind of debating like, why can't we support this atomicity bit? Why do we care about like just a pod template and not multiple pod templates. And I think there was this kind of general idea that when you design a provisioning request to be like with pod set such that it's like fulfillable essentially, you almost change the semantic from something that's declarative to something that's it's still declarative, but it's completable. It's kind of like the difference between a deployment and a job. Like a provisioning request would finish once the capacity has been consumed, essentially. And so we just kind of, at least in my head, I was kind of thinking about this, how you have this primitive of pod in Kubernetes, and then you have higher level orchestrators that do things with pods. And the immediate question was like, okay, well, how come Q can't, like if Q needs the atomicity and we have this primitive that can launch capacity that, fakes pods without all the rights to the API server, shouldn't the individual orchestrator be doing the atomic request itself? And the basic example we came up with is like often when you're doing a batch workload, you can do dynamically sized workloads. So you might ask for 10, and then if you only get 8, your batch orchestrator might actually decide, you know what, even though I only got 8 out of 10 and I couldn't get those last 2 GPUs, I'm actually just going to reshuffle all my indexes for my job and execute it anyways. And so that there's a lot of orchestrator specific business logic that you might want to reason about at that layer essentially. And that by pushing atomicity down into this provisioning request object, you force provisioning requests to then become aware of all of these different nuances around how orchestrators might want to use it, which in my mind was kind of a similar relationship between pods and the higher level orchestrators of job and daemon set controller and all those things. And so that was kind of our solve for the atomic use case, is that we have this primitive works in all these ways. We've lost this use case of atomicity, but surely atomicity could just be solved at kind of a layer above.
I think you actually see, I mean, to some degree, you kind of see that with this. Like in my mind, like these two classes kind of express what Ellis is talking about to some degree. Like Q is needing these kinds of things, and so we're having to push them down into the, as far as I understand it, like Q needs this kind of like check capacity and like atomic scale up. So we're like pushing it down into this API object that Cass is reasoning about. But maybe Cass doesn't care. Like I don't really think Cass cares so much about the semantics of these things, right? Like maybe the check capacity that potentially is an interesting use case that we hadn't necessarily thought about, although I'm not sure exactly how we would reason about that. But like that we're having to like continually, like we're gonna have to keep pushing more features down into this API. I kind of agree with.
Yeah, I think again it's difficult discussion to have without Marcin, but I think, and I don't necessarily think it needs to be one or the other use case. I think we probably need something that ideally addresses all the use cases. But I think specifically the problem is you probably don't want to have I don't know. I don't think Q wants to be Cass or Carpenter. I think it wants to sit on top of Carpenter or Cass, right? Which makes perfect sense. Why would you? There is a lot of work to creating VMs and so on. So yeah. I'm sure you know that. And I think then the problem is specifically if I can request all of those instances in atomic way with all or nothing semantics, I want an API to do this via Autoscaler. I don't want to make the request in my system, right? So if such capacity exists, then that is where it becomes useful. I'm wondering, right, if it's possible, and this is my thinking, which I'm not sure that Marcin would agree with, if there are different ways of satisfying those different requirements, of specifying different requirements. So you mentioned like the usual case would be one pod spec, right? But maybe there is this specialized use case of job set of that Q has, which is multiple pods because I just have those kind of all or nothing gang scheduling use case that involves pods with different specs. And then it's useful for me to express it as a set of pod specs. And then maybe there is also this use case of floor capacity, where it's maybe pod spec is not even the most convenient way of expressing this. I'm wondering if, like, what if we had a union, right, where you can specify capacity in different ways? I don't know. It's just me making stuff up, because especially with the floor, like pod-based specification and kind of template-based, instance-based specification, that's actually quite far conceptually. So I don't know if shoving it into one API is the way to go, but it's an idea that can be considered.
Yeah, we did kind of discuss this. Like, we were kind of exploring the idea that, you represent instance capacity as like pods basically, and like how do you do that? And do you have to create like additional semantics, like unnecessary, what feels like unnecessary semantics on top of the existing like pod API, just because you need to like you want like a unified concept. And so you do end up, I do agree to some extent, like you do end up like this is basically us like trying to explore like what does it look like if we try and build like a floor for nodes. Like effectively you end up having to specify like here's the instance type I want to spread it across zones. Maybe you do or don't need this. You like have to basically create an anti-affinity construct to like say like here, give me headroom that represents this instance type, and like spread it across different nodes, which basically means like give me different nodes, and then that headroom is like satisfied by anything. So like that's your like floor capacity, right? Like any pod satisfies this like headroom. The headroom has to be spread across multiple instances, and therefore you will get, like in this case, you'll get 3 instances all the time, and all the like it'll basically be your floor capacity. I think what we ended up coming to is that like you want things like topology spread. Like maybe the affinity concept is kind of annoying. Like this is like the annoying piece that's like, why can't I just like assume that it's like node headroom, and node headroom automatically has this like underlying concept of affinity and anti-affinity, like just out of the box. Like, why do I have to specify this whole thing? But I think you do want things like topology spread and node selector. And so you're kind of like almost like we tried to explore like what it would look like if we didn't do like the affinity piece, and it ended up looking like quite similar to a pod spec. Like maybe you lose a few things, but you're just kind of like creating something that's familiar but not the same. And then
It was annoyingly different. It was like
yeah,
almost like it, but kind of for quote unquote reasons, various semantics just suddenly worked differently. And so then you're in the space of trading off. Well, you do have a new API, and that API does more naturally fit the problem, but the API is very similar to another API, and it's net new and behaves in slightly different ways, which we just realized was like, at least, I mean, it's definitely a design option that's on the table, but it felt like from a user perspective, just simply understanding one concept of headroom that was flexible, it was going to be less cognitive burden than trying to understand 2 disparate but similar concepts of headroom. I think we called it like cluster headroom and headroom. Like one is like at the node level, globally scoped, and the other is at the namespace level at the application scope.
So you're saying it's actually more convenient, or like maybe easier for users to express this cluster headroom as a set of pods that just enforce something? Because like my imagination would be essentially a node pool, like link to node pool plus like 10 as I want 10 instances. And if you want specific topology constraints, like maybe you need to express that somehow. But
yeah, I think we're back to like, does topology spread constraints make sense in the context of a node pool, like on our side, like in the case where you're not specifying like a static set of nodes. Like if you're just like doing it, like if now you're having to overlay the concept of like pod topology spread with the concept of like node pool topology spread, and maybe you just say like this like part of the semantic, like this part of the spec only applies when you're doing a static set of replicas. But now you've got like this weird like divergent behavior that happens in like some scenarios but not others, and I don't know, it feels like when you're doing that, it almost unnaturally fits in that space. And like you're kind of, I guess the more we explore that option, we were like, well, this is kind of like, it makes, maybe it's a little bit annoying to have to specify this at the like the pod layer, but it kind of feels like it naturally fits at the pod layer. It's like the pod spec actually naturally kind of expresses the constructs we're trying to get at. But
sure.
Yeah.
I don't have particularly strong feeling, just because I feel like for cluster autoscaling, the default solution is you just set mean size on your node pool. So then, because we already have this concept of mean size, right? And then we just add nodes to the mean size, and then you're done. So there's completely different way of doing this. I don't know to what extent CAS users would be interested in this use case, because like if you start from having mean size, that just feels like you're reinventing the same thing.
Wouldn't NAP users or Google Autopilot users be interested in this? Can you create node groups for Google Autopilot, or is it just NAP?
It's just NAP. You cannot create it.
So there's, I think this is how Autopilot would work.
Yeah.
I suppose.
So the way we do, so in Autopilot, it's more complex because Autopilot has per pod pricing. So that kind of creates different sort of challenges. I don't know what the answer is here. But obviously just I want 3 instances doesn't fit super well into that.
You would have to price the headroom. I think the only way to do that would be to price.
Yeah, but then that I think requires a lot of product discussion around pricing and so on. So this is maybe very specialized use case. I think for NAP, we do have minimum size extended to NAP where you just say, yeah, it's different node pools. I mean, GK node pools, but you still specify like minimum calls and maximum calls total across everything, which is maybe less definite. But also with NAP, you can still use normal node pools. So if you really want, I want specifically a like floor of X capacity, you can still create a node pool that has certain minimum size, and actually NAP will not take that node pool below that size, if that makes sense. So there is a way to do this. Maybe that would be more useful with NAP, that's true, but it's not entirely obvious.
What do we? We want to set up some time with Marcin. Do we feel like?
Yeah, let me talk with Marcin and ask when would be good time. I think next week is probably because I know Monday is off in the US, and then Thursday and Friday are days. Thursday is day off in Poland, which pretty much makes Friday also day when no one is here. So maybe like 2 weeks. In 2 weeks would be better, given like all the long weekends on different in different countries.
Yeah,
but I also need to actually ask Marcin. I don't know what his calendar is, so let me ask him, and I'll put some date on Slack as a proposed date.
The question for me is whether or not this would block the beta. I think one of the things for us is we wanted to engage. We've been really focused on other things and are still focused on V1, but just from the discussion last week, like we really wanted to engage on this topic as soon as we could and just get these ideas out. I think I don't know, I think probably my preference, unless Marcin or yourself feel very strongly about promoting to beta, that if we can in 2 weeks kind of get a doc to debate the alpha, we should debate the alpha just because it's going to minimize churn on users. And then we can make like a beta call then. Are you guys comfortable deferring the beta promotion? I don't know where that is right now, but deferring that for a couple.
I think because Marcin is driving this, I would rather he was involved in that particular question.
Sure. Do you know where the beta promotion process is right now?
It haven't been done yet. I know that. I can follow up. Okay.
And it's maybe not the biggest deal, but it definitely feels like we're super close, I think, to having the debates we should have had in November or October when this was originally coming out, and we just didn't have time to chat about. So if there's anything we can do just to kind of get that conversation kicked off, maybe we schedule something out of week or out of band sooner. We're very happy.
Yeah. I think for scheduling, since again, I think Marcin is necessary for this discussion, and I don't know his calendar. Let's align this on Slack for like planning the day to meet. Yeah, let's have this discussion, including Marcin, because he's the main person driving this from our side.
Cool.
All right. So I think we're out of time. So thanks, and let's schedule the next meeting on Slack. Then I guess on the provisioning request specifically.
Sounds good. Cool.
Thank you. Bye.
So long.
Thanks.